welcome to Who Wants to Be a Billionaire? I'm your host, Heave Barvey. Today our guest is Randy Mathematics.
Hey.
Alright, you're probably wondering, why is Randy Mathematics here today?
I'm really poor and I need money.
Alright, there's two questions, and if you get both of them right, then you get $500. If you don't know one of the answers, then you can use your phone a friend, and then you also get two bonus help things as well. Alright, here's question number 1.
Oh, I know how to do this.
Question 3 asks, the function f is differentiable on a closed interval -6, 5 and satisfies f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. Part A asks, find the values of f of -6 and f of 5. So the main concepts behind this question are knowing the relationship between f and f prime, as well as integrals and some geometry as well. So we're going to start with -6 over here, and we know that f of -2 equals 7, so you can actually use this to create an integral as we laid out in this format above here, and we flip -2 and -6 so it works out, but you also have to make the integral negative, and that leads to 7 minus 4, which equals 3. The same strategy as -6 can be used in 5 as well, where we use f of -2 equals 7 to create an integral, and because 5 and -2 includes a semicircle over here, you actually have to work with pi, and you get 7 minus 2 pi plus 3, and you can simplify that to 10 minus 2 pi. So this is the rubric for question 3 part A, and you get a point for using initial condition, which basically means laying out the information that was provided for you. So in our case, we used f of -2 equals 7, which was given to us, as well as getting both parts of the question correct, so -6 and 5. A common mistake associated with this question is thinking that this is a graph of f and not f prime, so people think that they can use this graph directly to get the answer. And you can see for this student, they believe they could use f of 5 from this, which is 0, and use that as their final answer, which is incorrect.
It's like question 1 actually has 4 parts. Alright, part 2 of question 1.
I think I need to use the phone a friend.
Hey, Mr. Starby. I met Randy at a Safeway in 2003. I was buying peanut butter, and he tackled me, then ran me over with his cart, because I was buying chunky peanut butter. After that, he showed me that smooth peanut butter is better, and we've been best friends since. So, for the math question, we know that f prime is given on the interval of -6 to 5, and we know that's going to mean that f is going to be continuous and differentiable on that interval. Because of that, we know that f is going to be increasing on the intervals where f prime of x is greater than 0. That means that f is increasing on the intervals of -6 to -2 and 2 to 5. You can see that if you look on the graph. So the scoring for this question is pretty simple. There's only 2 points and you have to earn them together, and they're awarded if you provide an explanation with the right justification. A mistake that people usually make when they answer this question is not explaining that f prime of x is greater than 0 on the intervals of -6 to -2 and 2 to 5. Just stating that f prime of x is greater than 0 isn't actually enough to earn full credit.
Now for part C.
Can I use my bonus help, Mr. Starvey?
Hi, Heave. I'm a street performer he cursed out because I was making too much ruckus. When I declined to stop my music, he promptly kicked me in the shins and ran for the hills. He also took all the money I made that day, as well as the hat I was using to hold it. In regards to the problem, though, to find the absolute minimum value of f of x on the interval, we must first consider what x values could possibly produce the minimum. The minimum could exist at either endpoint on the graph, x equals -6 or x equals 5, but it could also exist at x equals 2 or x equals -2. This is because when you take the graph of f prime of x, they produce a result of 0. Now to find the minimum, you determine the y value of each x using f of x. F of -6 is 3, f of -2 is 7, f of 2 is 7 minus 2 pi, and f of 5 is 10 minus 2 pi. Therefore, the absolute minimum value of f of x is at x equals 2, where f of 2 is 7 minus 2 pi, given that it is the lowest value using these four x values. For full credit on this problem, you get 1 point for considering x equals 2 as a possible minimum value, and 1 point for justifying that the minimum is at x equals 2. Common mistakes on this problem will include not considering x equals 2 as a possibility, or accidentally finding the minimum of f prime of x instead of f of x.
Alright, and now part D.
Can I use my bonus help, Mr. Starvey?
Hi, Mr. Starvey. Yeah, I know that, Randy, because I'm metal. To find out whether or not f double prime of -5 and f double prime of 3 exists, and their values if they do, we can simply look at the graph of f prime of x that is provided to us. From the left and right of f prime of -5, the graph of f prime of x approaches the same value at f prime of -5 with the same slopes, which means that the graph is differentiable at that point. This means that f double prime of -5 does exist and we can find its value. In this case, because f prime of -5 lies on a portion of the graph that is a straight line, the derivative of f prime of -5, or f double prime of -5, is simply the slope of the line that f prime of -5 is on, which is -half. This is because the derivative of a point on a graph is the instantaneous slope of that specific point, but on a straight line, the slope is consistent across the whole line segment. Therefore, as for f double prime of 3, it does not exist because f prime of 3 is not differentiable. F prime of 3 is not differentiable because although it is continuous, two completely different slopes approach f prime of 3 from both sides. This makes f prime of 3 undifferentiable. In order to get full credit for this problem, you need to state the value of f double prime of -5 and state that f double prime of 3 does not exist, along with a correct explanation as to why.
Alright, the final question.